Saxon Algebra 1 half, lesson 101. Students, we have made the leap into hyperspace. We are beginning week 2 of 6. So we've got 5 weeks to go. That is very exciting. I want you to know that 4 of our students have decided that they are ready for running start and they are preparing to take the test called the AccuPlacer that you take to figure out what classes you are ready for at the college level. And my job is to help them test into the college level math classes, even though they're in high school, because the Saxon curriculum is so good, they are ready for those classes, college level classes for high school kids. It's one thing to do English and history and that kind of thing at Running Start. That's great too. I take nothing away from that. But to do math, college level math as a high school student is extraordinary. You guys will soon be there. Just a couple more years and I will whip you into shape too. I mean, you're whipping yourself into shape. What am I saying? But there's an intensive review process that we go through before they take this test. And so Abby Saboran, Jayla Judd, Laura Rice, Vivian Rice are the 4 girls who are taking it this year. So they are our math heroes and I'm really proud of them. Okay, and you guys are well on your way. And I hope you're planning on that. No matter what your future might hold, going to Running Start and taking college classes for free as a high school student is a fantastic way to live out your high school life. It is absolutely great. I recommend it highly. So start thinking about that and pay attention to the kids you know who are going to Running Start and just listen to what they have to say about it. It's really cool. I'll tell you more as we go. But now I want to do this fabulous lesson with you. 101.1. Simplify. By the way, before I tell you what the product rule is, I'm going to show you how it works because then the rule will make a lot more sense. Okay, let's say that we're multiplying these 3 numbers, 5 squared times 5 third times 5 to the 4th. Notice that it's all 5s, right? The bases, if you will, 5, 5, 5, are all the same. Now, 5 squared means 5 times 5, right? And 5 to the 3rd power means 5 times 5 times 5. I can't say it anymore. I'm going to stumble over my mouth. The exponent tells you how many times the base is being multiplied by itself, right? So if we want to multiply all of these together, I wrote each one out. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can write the answer as 5 to the 9th. And we could simplify that, but that's not what we want to do right now. We just want to leave it as an exponent. That's our answer. Okay? Now, let me do another one, and then I'll show you how the rule works. This time, our base is 10. Okay? Last time I wrote it all out like this. I'm not going to write out 15 tens and then 17 more. I would like a rule that is easier. And what I saw in this one is that if I add just the exponents, 2, 3, 4, it's the same thing as writing them out, right? I don't need to write them all out. I can just add together the exponents and we write it like this. You can just make a little addition problem up there. And I get that the answer to this one is going to be 10 to the 32nd power. This was right, and this is right. Okay? This is way easier than drawing it all out and completely unnecessary. All we have to do, if the bases match, and I'll keep stressing that, because if the bases don't match, it doesn't work. It's only when the bases match, the base is the big number, PS, then we can add the exponents if we're multiplying them together. That's the other thing. We're multiplying matching bases. We add the exponents. Now, what about something like this? this is what I'm saying. If the bases don't match, you got nowhere to go. There's nothing we can do to simplify that. And in fact, we would just say that's the answer. We could always multiply, this is 8 and this is 25. We could multiply it out like that, but right now we're just trying to see if we can simplify the exponents. So it has to be a matching base. Now, those are 3 examples that show how this works. Now I'm going to show you the way we memorize this product rule. P.S. The product rule we're going to use forever. We're going to use it for years to come, right? So this is going to be burned into your head with a wood burner. Ouch, wouldn't that hurt? You know what a wood burning kit is, right? It's like a hot piece of metal. And it's like being branded, let's be honest. I'm going to brand this. I'll brand it into your brain, not literally, but figuratively. This is how we write it. If you have a base that's raised to a power. Now we use letters to make it kind of like apply universally, right? And you're multiplying that by the same base that also has an exponent. You can simplify that by adding together the exponents. And we call this the product rule for exponents. It's super important and useful. Okay, matching bases, exponents, we're multiplying them. That allows us to just add those together. Okay, so let's try a slightly more advanced type problem because we're ready for it now. We have 2 more to go. This is long, so copy. I'm gonna make that one darker. Okay, I'll double check while you write. All right. Now, it's kind of like adding like terms, isn't it? We can't use our product rule unless the bases match. So the first thing we want to do is go through and look for the matching guys. I'll start with X. I like to go alphabetical. There's an X, there's an X, there's an X. Okay, I'm going to add the exponents. But I go to this first one and go, there's no exponent on there. What do we do about that? Do we just not add it? False. What we do is we put in a 1. X can be written as X to the power of 1. X meaning any number or letter. We can put on the 1 or we can take it off, whichever is easier for us. So for our X values, we'll have X to the 1 plus 2 plus 4, and that equals 7. Okay? Now we look at our Y's. I'm going to circle those so that I can tell them apart. That means we have Y to the 17 plus 6, and that equals 23. Am I right? So now we can write our final answer, X to the 7th, Y to 23rd. Yay! Make sense? I want to recognize this as the type of problem that gets a little tricky to write neatly. I'm looking at people who write small and fast. You're going to have to make an effort to make sure that your exponents are clear and easy to read, but also different than your bases. See how I really exaggerate my bases so that I can still write my exponents big, but you can tell it's not a number? You can't write something like this. Just a second, I wrote it wrong. You can't write that because those don't look like exponents. No bueno. It has to be very distinctly floating up in the corner of the letter. So you're going to have to slow down a little bit on these problems and write neatly so that I can tell. If you put this on a test, I would not give you that. I would not mark that as the right answer because that's not presented correctly. Does that make sense? So be neat, be careful, and think about making sure you're expressing those in the right form so they actually look like exponents. And then here's our last one. Ready? All right. You write while I check. Beautiful. Same as last time, except what I like to do, now that we know the trick of these letters with no exponents, as I'm writing the problem down and copying it from the book, which I do recommend that you do, just automatically fill in any letter that doesn't have an exponent, give it a 1. You can do that right away. Okay, and this time I'll not talk. You do it and I'll do it, and we'll compare answers at the end. Here's my answer. Okay, that, my friends, is how we use the product rule for exponents. It's when we're multiplying matching bases, we can just add the exponents. Yay! Important learning in our brains. We'll come back to it many, many times. Don't worry. It's going to be with us for quite some time. Okay, thank you. Goodbye.